Bismillahirrahmanirrahim. This lecture is prepared for BSTS students for complex variable and transforms. Now the topic is actually even and odd functions. How we are going to define the even function and odd function. A function f of x is said to be even if f of minus x is equal to f of x. Okay, so such type of function, when we are going to replace the argument x by minus x and it gives you the same function, such type of function will be called an even function. Examples are cos x, or any function f of x is even where power on the variable x is even. So, and any even power of x is also even function. Okay, so just you can see the graph of even function, which is basically the graph of cos. As cos 0 is 1 and cos pi by 2 is 0, so this is an even function. Now the other properties, I will come to that things also, that even times even on the left side, even times even will give you even, odd times odd will give you even, and even times odd will give you odd. But you will get understand that when you when I will define odd function as well. So there is a comparison between even and odd function. Even functions are basically symmetrical about the y-axis. If you look over here, these are symmetrical about the y-axis, and you can see if you put a mirror over here on the y-axis, it is exactly the reflection of the same image. Okay, so a mirror image basically give you an even function. So even functions are symmetrical about y-axis, whereas the odd function, which I'm going to define, the odd function basically, when we say f of minus x, if you're going to replace x by minus x, f of minus x will give you minus time f of x. That will become odd function, and odd function are symmetrical about the origin. Here, for the beauty of even function is that if, for example, if a function is even function, then a curve from minus c to c is double the area from 0 to c. Here it goes that integral minus c to c f of x ds will give you the same area, if I can say 2 times integral 0 to c f of x dx, as it is clear from the graph as well. A function f of x is said to be odd if f of minus x is equal to minus time f of x, as already I told you. Any odd power of x is an odd function of x, and so are sine x and sine 2x the same way. So sine function is basically an odd function. The graph of such a function is always symmetric with respect to the origin. The interesting thing is that the area under a curve from minus c to plus c is 0. Here you can see the integral minus c to plus c f of x dx is 0. This is for odd function.